Hi everybody. I'm going to show an example of how we can use information contained within spatial data frames to do a little bit of data processing within the spatial data frames. And I'll try to help you understand what I'm going to do just with a general problem. Let's say you have a spatial polygon data frame. You have a bunch of polygons and they're adjacent, some are adjacent to each other, some aren't, and you want to aggregate or count up some value or do some other operation involving the neighbors of polygons. So for every polygon, maybe you want to sum some value across all the neighbors. There are a lot of different ways to do that, and I think there are methods that are quicker and easier and cleaner. But this is showing you the bare bones way to do it so that you can approach the problem more generally, so that if you've got any sort of unique challenge or unique operation you want to perform, this is a framework for doing it. The first step here is to create the data, and that's what I'm doing here. So the three libraries I'm using are these three here. The first one is for creating the Voronoi tessellation that we'll use just to create the data set. The other two are used, one is used in the projection process and one is used for calculating the nearest neighbors. So I'll do the first step, the creating data step. And what you see here, if you look in the bottom right-hand corner, this is the data that we're working with. We've got 5 polygons, each of which, if you look here, there's a little gray number. These are the numbers, the IDs, assigned in the creation of the spatial polygons data frame. So I didn't create these, but they're created as part of the creation of the spatial polygons data frame. And if you look into it, you can see here ID is created, this ID. In addition to that, I've got a label. Now these characters here, A, B, C, D, and E, these are ones that I've assigned. And plus we have a variable that's measured across these polygons. So we have values associated with the 110, 10, 50, 20, 20. We have all these values. We have a nominal identifier here that I've created, as well as the ID that's contained within the spatial polygons data frame. Now, the next step here is I want to create a list of neighbors, and I can use this poly2nb function contained in spdep to do that. And if we take a look here, you can see that it's a list. Each row here corresponds to a polygon in the spatial polygons data frame. This is polygon 1, 2, 3, 4, and 5. And the numbers correspond to the neighbors of that polygon. And you can verify this by looking. We can see that neighbor 1 here, or polygon 1, is neighbors to 2, 3, and 4. And that's what we see here, 2, 3, and 4. Polygon 2 is neighbors to 1 and 4. And we can see that here and so on. Now, like I said, what I want to do is create a new variable for each polygon with it is the sum of the neighbor values. And the easiest way to do this, though probably not the fastest if you have a very large data set, but I think it'll probably work okay, is to do this in a loop. However, it's tricky because you have to understand and be able to access the structure of the list in the right way. So you've got this list of nearest neighbors and the structure of that list, and we need to use the information here to actually sum up the values. How do I do that? Well, let's look. It's going to be done in a for loop. This is the easiest way to kind of see what's going on. But I want you to look in here first. So look here. This little thing here. So what this is doing is it's in order in which they're contained within this list here. It is getting the list of neighbors that correspond to each polygon. So when I equals 1, it's getting the list of neighbors for polygon where the ID equals 1. When I equals 2, it's getting a list of neighbors for the polygon which has an ID equal to 2, and so on. So that's what's happening in this part here. And then what it's doing is it's accessing the values that correspond to that identifier. Because if you look in the spatial polygons data frame here, you can see we have got values, V here, these are the values, and each one of them correspond to one of these areas. And I'm accessing them using the identifier that comes out of the nearest neighbor list. And then I'm using that, which is a vector. This is actually a vector of nearest neighbors, using that vector and putting it inside this reference here, which is a reference to the actual data themselves within the spatial polygons data frame. And then I'm summing them up. So I'm summing up all the values. When I do this here, this step, I can plot it all out. What you get at the end are these values here. These are the summed up values. And again, you can verify it visually. For this area 3, its neighbors, its total equals 180. And we can verify that. We can take the neighbor values, which is 110 plus 20 plus 50. That equals 180. For this area 4, its total is 190. 20 plus 110 plus 10 plus 50 equals 190, and so on. And so we can verify that this worked by just looking at it. And the basic idea here is that this can this can be really, really useful if you need to do spatial operations and you don't want to have to manually do anything or clumsily calculate things by hand or in a data table. You can all do this in one step. If you have a list of neighbors, you can use the indexing, which amounts to this ID label here, to help find values associated with observations within that spatial polygons data frame, because 2 is effectively an index that points, in a manner of speaking, to a location in this vector. So here that 2 points to this location, and the 3 points to this location, and the 4 points to the 4th location, which is right there. So 2, 3, and 4. And and this is how this works. This is how the process works. We can take the values and we can add them up this way in a way that ultimately is pretty useful for saving time. Well, that's all I have to say for today. Hopefully that's useful to you, and I would invite you to play around with some real data and see if you can sum up values this way. Sum up neighbor values, take the averages, really any operation you want to perform in a vector, actually you can perform on it, which can be useful. And it's an elegant way, it's a fairly elegant approach to calculating spatial data. All right, bye.